Okay, section 4.3b, we are talking about using the factoring method for solving quadratic equations. Actually, in the previous video, we were dealing with quadratic expressions, and so the only difference that you're going to notice in these problems today, and I'll scroll down so we can look at some of these here. Oh, I think this may have gotten cut off here, is that these are now equations. So you'll notice there are equal signs here. And yesterday's problems, these were just expressions. There was no equal sign here. So these problems are going to ask us to do one extra step at the end. Because the goal is to solve for x, in the end, we'll need to say what x actually equals in that problem. Okay, so a few things here that I just want to mention to you is when you are doing the factoring method, before you do any factoring, there are basically 4 things that you need to make sure that you do if your problem is an equation, okay? The first thing you need to do is you need to make sure that you have moved all of your terms all over to one side of the equation. Okay, so they all need to be moved on one side. Once they're all on one side, you then need to rearrange them so they are in descending order. That means the largest exponent is first and it progressively gets smaller. The third thing is you want to make the lead coefficient, okay, the term in front of that x squared needs to be positive. So if it's not, you would just factor out a -1, and we're going to be able to practice a problem like that today. And then this is so important. The fourth thing that you should do before you actually categorize what type of factoring problem you're dealing with is you need to make sure that you check for a GCF. Okay, so often students forget to check for a GCF and they think that it's a problem in which you cannot factor when, in fact, had they removed a GCF, they then would have realized that there was some factoring then that could also take place. Okay, so if you recall from yesterday's video, we had 4 types of factoring problems, and in this box they progressively get more difficult here. This is just a review and has those same things listed. Okay, I want to draw your attention though to the second box, to something called the zero product property. Okay, because this is relevant when our problems are equations. See, yesterday you would have factored the problem, and maybe your answer would have then looked like 2 binomials possibly multiplied together, like x plus 3 times x minus 5. Okay, now since these problems are equations, remember up here we said the first thing you do is you're moving all the terms to one side of the equation. Now you're going to have these 2 factors that are equal to 0. Okay, now think about what's in between these parentheses. There is multiplication in between there. So what we're basically saying is we're taking 2 numbers, and we're not sure what number x plus 3 represents, but it's representing a number. And then x minus 5 is representing a second number. And we're saying if you multiply these 2 numbers together, their product is 0. So I want you to just take a second and think of any 2 numbers. Okay, the only restriction is that when you multiply the 2 numbers that you are thinking of, they have to multiply together to be a 0. Okay? Now, true or false? If you're thinking of 2 numbers whose product is 0, then at least one of your 2 numbers has to be the number 0 in order for them to multiply to be a 0. Okay, that's true. One of the 2 numbers has to be a 0. Okay, so that's what the zero product property is saying. It could be this first factor, x plus 3. That might be the one that actually is equaling a 0. Or it could be the second factor, x minus 5. That could be the one that equals 0. So what you end up doing is you end up taking each factor, you set each factor equal to 0, and you solve these little miniature equations here for x, and that's how you arrive at your solution. You often have 2 solutions for quadratic equations. We know that if you remember from graphing, a lot of times there are 2 x-intercepts on the parabola, and so a lot of times we get 2 answers even when we're doing the factoring method here. Okay, so let's go ahead and do a problem here from the very beginning. We're going to take a look at example A. We can see this is an equation. Okay, the first couple steps I had listed above this box here have already been done for us. All the terms are already all moved to one side. It looks like the terms are already in descending order here. Okay, my lead coefficient looks like it's already positive. I can see I have a 1 here in front. I do want to check, though, to see if there's a GCF that I could remove from each of these three terms, and it doesn't appear that there's anything that all three of these have in common. Okay, so once I've done those four things, now I can come down to this box and say, okay, well then, what type of factoring problem does this fall into? Okay, well, if we checked for a GCF and we said there wasn't one, it's definitely not this first type, because this first type is assuming that you did factor out a GCF and then you couldn't do anything more. So it's not number 1. Number 2, a difference of 2 squares. Well, to be a difference of 2 squares, I would have to have at least 2 terms here, and there would be other requirements, but I can see this is actually a trinomial. So that kind of narrows it down to either type 3 or 4. Okay, 3 is when my lead coefficient is a 1, which is what I've got right here, and 4 is when it's not a 1. So I'm going to go with this is type 3. Okay, and you'll notice it says here, start with an X chart. So I'm going to make a little X chart off to the side. I'm going to put A times C in the top. I'm going to put B in the bottom. A times C would be 30. B in this problem would be negative 11. I'm going to go ahead and make 2 parentheses. I'm going to put an X at the beginning of each set of parentheses. I'm going to go ahead and keep my equals 0 because this is still an equation, so please keep that part there. And then you're going to think through 2 numbers that would multiply to be a positive 30, but they have to add to be a negative 11. Those 2 numbers would be negative 6 and negative 5. So to finish this problem off, you would then need to take x minus 6 and x minus 5, and you can do this part in your head here. I'm just going to write this down here so that you see what we're doing. You would set each of those factors separately equal to 0, and then you would solve each of those little kind of miniature simple equations for x, and you would get your 2 answers of x equals 6 and x equals 5. Okay. All right, let's go ahead and try example B. Okay, here we can see that all the terms have already been moved to one side. It looks like they are in descending order. My lead coefficient, that's my 30, it's positive, so I don't need to factor a negative out of everything. However, it does kind of feel like there is a GCF that we could pull out of all 3 of these terms. 30, negative 16, and 2. I think I could remove a 2 from all 3 of those terms. Okay. Remember, when you're factoring something out, what you're actually doing here in your head is you're dividing each of those terms by a 2. Okay, and the last term then, 2 divided by 2, that would become a 1. Okay, so I've got the GCF out. Now, I need to figure out what type of factoring problem this is. Okay, so I did factor out a GCF. I want to look at what remains behind here, though. I have a trinomial left behind here. So I'm going to jump down to 3 or 4. It's a trinomial, but look at the lead coefficient on this. The lead coefficient is not a 1. Okay, so it's a 15. So that means I'm going to be factoring by grouping. If you recall factoring by grouping, that's when you draw the 4 blank lines. Now, here's the catch with this. I pulled a GCF out of this problem. So because I pulled a GCF out, I don't want to lose that 2. I need to keep the 2 in every step of my work. So I'm going to upgrade the parentheses into a set of brackets. And then inside the brackets, I'm going to put those 4 blank lines. Okay, if you remember, the first term goes on the first blank. The last term goes on the last blank, and then off to the side, we make one of those X puzzles, okay, or X chart. Okay. We're supposed to take A times C, that'd be 15, that goes in the top, and then the B value, that goes in the bottom, negative 8. Okay. We need 2 numbers that multiply to be positive 15, but that add to be negative 8. And those 2 numbers would be negative 5 and negative 3. Now, it doesn't matter technically which one you put on which blank, but when you place them on those middle two blanks, do make sure that you put an X next to each of the two numbers. Okay, now the next step, this is why it's called factoring by grouping. You're now going to group the first two terms together and the last two terms together. Now, this could easily get confusing because you have this extra GCF that's already sitting out in front. So make sure you keep that 2 sitting out in front. This is why I like to upgrade those original parentheses into brackets. And now from the first group, you're going to try to pull a GCF out of a 15x squared and a negative 5x. And the GCF that we could remove from that is a 5x. So I'm going to divide each of these by 5x. That's going to make the first term a 3x, and it's going to make this term right here a negative 1. Okay, that's going to be a negative 1 here. All right, now if you recall how this works, what you're wanting to do is you want to factor something out of the second set of parentheses so that what you leave behind will match what you have left behind in the first set of parentheses. This almost looks like it's matching now. The only difference is this is a negative 3x and this is a positive 3x, and here we have a positive 1 and a negative 1. So for me to get it to match, I'm going to need to factor out a negative 1. So I'm going to divide each of these by negative 1. That's going to make this 3x minus 1. Now my quantities here match, so I can treat that quantity as a GCF. I'm going to pull 3x minus 1 out. That leaves me with the quantity 5x minus 1. And then don't forget about your GCF. That 2 needs to be sitting out in front. Okay, now if this was not an equation, we would stop here and our answer would be these 3 factors. Since it is an equation, we do have 3 factors. However, you're only going to set factors that have a variable in it equal to 0. So that extra constant 2, it does need to be there, but it's not going to produce an answer. Okay, and then you're just going to move the 1 to the other side, divide both sides by 3. We get one answer of 1/3, and we get another answer of 1/5. Okay. All right, let's take a look at example C. Here's what always happens with example C. People forget that this section is focusing on factoring. If you look at the directions, they ask you to solve by factoring. Don't write this down, but this is what everybody does every time they see this. They think, oh, we're solving for x. I'll take the square root of both sides, and they write down that x is plus or minus 7. Which is actually the correct answer. Okay, it is plus or minus 7. However, oh, I'm sorry about all that mess there. Let me see if I can just get rid of that. There we go. This will be a little bit cleaner. You do have to do the problem the way the directions ask, okay? This is all about factoring. We want to go through our steps of you really need to move that 49 over so that everything's all to one side. Needs to be in descending order, which it is. Need to check for a GCF. There isn't one. So then I'm going to come down and I'm going to say, well, what kind of factoring problem is this? Well, it's not a trinomial, so it's not going to be 3 or 4. It's not number 1 because I didn't pull a GCF out. So my only option here is that this is in fact a difference of 2 squares. And let me confirm that. There are 2 terms. Difference, okay, there is a subtraction sign. And then 2 squares, well, 49 is a perfect square. And my exponent on the variable is also even. So when I factor a difference of 2 squares, I do 2 sets of parentheses with a plus and a minus. I'm going to take the square root of the first term and put that answer in the first position of each set of parentheses. And then I'm going to take the square root of the second term and put that in the second position of each set of parentheses. I will then set each of these factors, I'm just doing this part in my head, equal to 0. Solving for x, I get negative 7 and positive 7. Doing that problem by factoring was probably much longer than doing just the square root of both sides, but you have to follow the instructions there. All right, we're just going to look at a couple more problems here, and then we will wrap this up. I want you to look at example A on the back, because here's a great example of a problem where the lead coefficient is not positive. Okay, so here you can see everything's to one side. It is in descending order. I don't think there is a GCF in these three terms that we could pull out. However, you'll notice the lead coefficient isn't positive. So what you're going to need to do is divide everything by -1. Okay, and just like you're pulling out a GCF, factor out a -1. Okay, that's just going to flip the signs on everything. Okay, then we're going to need to say, okay, now what kind of factoring problem are we working with here? Well, this is a trinomial, and I'm going to look closely and see, oh, okay, the lead coefficient here, it is not a 1, okay? So that tells me I need to do factoring by grouping. So I'm going to keep my -1. Inside the brackets, I'm going to draw those 4 blank lines. I'm going to put the first term on the first blank, the last term on the last blank, and then I'm going to come over here, I'm going to make one of those X charts. Okay, now here's where it's going to get kind of crazy. A times C, ooh, this is a big number. A is 12, and C is -15. So those two numbers multiplied together are -180, and the B value is -8. Okay, you always want to look at this step here. Don't look at the original problem. Look at once the lead coefficient has been made positive. 12 is the A, -8 is the B, -15 is the C. Okay, here's my advice to you. If you can't think of two numbers that would multiply to be -180 and add to be -8, what you should do is take -180, factor it down into we could just take 80, I guess, or 180 for now. Factor it down into prime numbers. Like, keep going with this until you only are left with prime numbers. And then group together the smallest factors leading up to the biggest factors, okay? Then you can you have a place from which you can like brainstorm different combinations of numbers, okay? For example, if I group these two 2's together and made that a 4, and then I grouped the 2 3's and the 5 together, that would be a 45. Here are one combination of two numbers, 4 and 45, that could multiply to be your 180, but I don't think those are going to add to be -8. Okay, so we're going to try a different combination. So instead of me grouping the two 2's together, let me go ahead and try something like this, okay? And sometimes it's a little bit of trial and error to stumble on it here. I'm going to group the 2 and a 5 together for a 10, and then I'm going to group the 2 3's and the 2 together for an 18. Okay, so if I do that and I make the 18 negative, I think I can get that to work where they'll still multiply to be -180, but they're going to add to be that -8. Okay, again, it doesn't matter which one you put on which blank, but do put an X next to each one. This is called factoring by grouping. So the next step is to group the first two terms and then the last two terms. You're going to remove a GCF from each group. The first group, you will remove a 6X. Remember, that means you're dividing each of these by a 6X. You will leave behind a 2X minus 3. From the second group, you're going to pull out a 5. Okay, that means we're dividing both of these by 5. You will leave behind a 2x minus 3. Do not lose the -1 that we factored out at the beginning, though. Okay, and then I'm going to factor out the 2x minus 3. That leaves behind a 6x plus 5. Here it's factored, and then I'm going to set each of these equal to 0. I get an answer of x equals 3/2 and x equals -5/6. Okay. The last problem I want to look at with you, this isn't actually listed as one of our types of factoring problems from the front, but I will just tell you that if you see a problem that starts out and there are 4 terms, so it's even bigger than a trinomial. If there are 4 terms, this is how I want you to treat this. I want you to imagine as if there were 4 blank lines. Someone filled in those 4 blank lines, but they just didn't finish the factoring by grouping process. So what you're going to do is you're going to group the first 2 terms together. You're going to group the last 2 terms together, and if there was a negative in front here, scoop the negative up in the parentheses and just squeeze in an addition symbol, and then remove a GCF from the first group. Okay, it looks like in this first group, 32xy and 40bx both have an 8 and an x in them. So if I pull an 8x out, that leaves behind 4y plus 5b. From the second set of parentheses, I'm wanting to leave behind a 4y plus 5b, so I should factor out a negative 3a. So I'm going to divide each of these by negative 3a. Then I would leave behind 4y plus 5b. I'm now going to factor out the 4y plus 5b, and that means that I'm leaving behind in the second set of parentheses 8x minus 3a. You'll notice that this problem was an expression. It was not an equation, so we're not setting any of these things equal to 0 and trying to solve. We actually have all kinds of